I'm in Master Industrial Engineering Option Chemistry.
What we want exactly is to make this operate.
We use some of their chemical research. So, we tried with
The experiment that we did in the second part. We made a big improvement in the floor to my colleague Alexei to explain more.
Hello, my name is Amnih Ismail. I'm 24 years old. I'm a student in Master Industrial Engineering Option Chemistry. As all first master students, our project for this year is about an automation of electrogravimetric dosage or deposition. Alexei and I takes care of all what is chemistry, and Mr. Junior takes care all what is automatic. This is our project. As I said before, contains two parts. Okay, electrogravimetric is a novel technique, experimental technique. But what we want from this project this year is not to do just a manually experiments in electrogravimetry. What we want exactly is to make this operation automatic. Now I give the floor to my colleague Alexei to explain more.
Hello everyone, so my name is Alexei. The project started last year with another group of students. We used some of their chemical researches to start the project, and we added some new ones. As said by Ismail, we tried to measure the deposited solid on the rotating anode. So we can see on the drawing here the anode right here with a motor. So to have a rotating anode, and we can see the cathode right here and the solution of ion of copper right here. So when we inject current or tension on the anode here, the ion of copper transform into solid copper, like we can see here. So the ion part transform into a solid copper and into the solid, and the solid copper just deposit into this anode right.
In the first part of the year, most of the experimental experiments have already been done. In the second part of the year, which we are in now, Mr. Junior have been succeed to automate the operation. The thing that he will explain to you. Now I will lead you with my friend Alexei to explain the experiment that we did in the second part of the year.
So during the second part of the year, we mainly worked on two different methods. The first one, we tried to determine which ion was better to use in our project for the future students that will use the deposition. So we tried with zinc, cadmium and copper, and to sum up, we saw that with the zinc we couldn't have any deposition on the anode. When with cadmium and copper, the deposition was visible and measurable. So the conclusion is that we used cadmium and copper in our solution to separate different ions. During the second part of the year, we also tried this new method that was able to calculate the yield of the deposition. So we inject a current of 400 milliamps for 30 minutes. And with these two information now, we are capable of calculating the number of coulombs that will go to the solution, So when we know the number of coulombs, we just have to measure the real mass that is deposited on the anode right here, and we can calculate the yield. So it's the real mass of copper divided by the number of coulombs, and we can multiply it by 100 to have the yield in a percent. Now let me introduce Mr. Junior for the automation part, which is based on the different chemical researches we did in the first two parts of the year.
My name is Steven, student in Master at ELA Mons. I'm going to show you the second part of this project, talking about automation, electrogravimetric deposition self using a microcontroller named Raspberry Pi. To operate, we need computer, we need electronic board, we need copper solution. We also need motor used to help a rotating electrode. By rotation, we can get homogenize the solution. To communicate, user can choose one of method in the Python program, the system. When user choose one method to command the system, information arrive on the Raspberry Pi through digital application interface. Raspberry Pi send again the information to analogic digital converter, and analogic digital converter send again information in the solution. To get feedback information, analogic digital converter can read information in the solution, send to Raspberry Pi, and Raspberry Pi can send again to computer. Then user can compare the value and check if okay or not, and can use another method to make electrode deposition. Thank you very much.
Thank you for the explanation. Now can you show me the device used for this project?
Yes, of course. Here is the rotating anode. You can see how this works. We have two different 3D printed pieces. Finally, electronic board connected to the PC.
As a conclusion, with the help of Serge Monnier, we are proud to say that we were able to automate a big part of the experiment, and we made a big improvement on the chemistry side of the project.